Hello, my name is Steven. Welcome to Hyfindr Tech Talks. Today, we are going to talk about electrolyzers, PEM electrolyzers for that matter. There are different kinds, but PEM is one where there's considerable growth at the moment, and we are lucky to have somebody here today who has deployed several systems all around the world. He works for NEUMAN ESSER, and I'm very pleased to welcome Max Ellerich. Welcome, Max.
Hi, thank you for having me.
Perfect. So, Max, electrolyzers, big topic. So let's go quickly into this. What is a PEM electrolyzer?
So a PEM electrolyzer actually is kind of a machine where you enter water and electricity and get out green hydrogen. So the water is being split and is feeding green hydrogen.
Okay, sounds like a magic shoebox put in there. But please take us one level deeper. What is actually happening inside, and what do you need to do to make it work?
Yes, perfect. So maybe let's start with a very tiny cell in the system, and then let's get bigger and bigger, okay?
Absolutely.
Because I think that's the best way of understanding that.
Yeah.
So if I'm looking at a cell of a PEM
we have
electrolyzer.
a cell of it here, right here.
Exactly. So this is like a cell with the plates and the membrane and so on.
Yeah.
And just explaining it easily, you feed water to the cell, and there's a voltage applied to it.
Yes.
And this voltage in combination with some catalyst is splitting the water into oxygen and hydrogen, right?
Okay.
So, what is happening then is very interesting. So the hydrogen is being sucked through a separator, which is a proton exchange membrane, which is why this is called PEM electrolyzer.
Right, there we come from. Okay.
Because I mean, the core of a hydrogen atom is the nucleus is a proton.
Yes.
So this proton goes through the membrane, and what you have left then in the water here on this side is oxygen. So you have water with oxygen left because the oxygen cannot pass the membrane.
Yes, yes.
And on the other side of the membrane you have the hydrogen.
Okay, so essentially you're pushing in water here, and then, as I say, you're coming out with water which has, well, obviously water plus oxygen because some hydrogen has left now, and then the hydrogen on the other side also with water.
Yes.
Yeah.
So there's an effect called water drag. So when the hydrogen passes through the membrane, it drags water with it. So this because of this, you have water also on the other side.
Okay.
You have very, very tiny amounts of oxygen, but at the ppm level.
Yes.
So oxygen cannot pass this membrane.
Okay, so this is one cell, and then how does this go in a bigger system?
So the point about this one cell is that it's only producing a little bit of hydrogen. So you need to have many cells to produce more hydrogen. So the idea of what you do is you add many cells on top of one another.
Yeah.
So it looks a little bit like this. It's always repeating, adding cells here.
Okay, so you're basically putting them one on top of each other, you're stacking them, and that's where the all famous word stack comes from, right?
Perfect, exactly, because you kind of stack cells.
Yes.
You stack like between maybe 100 and 200 cells to one stack.
Okay.
And then push a lot of water in parallel through all the cells.
Yes.
And then on the other end, get out water with oxygen and water with hydrogen.
All right, okay. So I read from time to time that, obviously we're talking about, megawatt systems, big, so there's probably lots of water going in and lots of hydrogen coming out. How does it look to make all this work?
Yeah, so the point is, as you say, I need to have a pump or a system that pushes the water through, that separates the hydrogen from the water, that releases the oxygen and so on. So maybe I can explain the system a little bit on how such a system can look like, what you have here.
So I know that this looks already very technical, but I know we have some pictures of the system later. So
Okay.
So please take us through this quickly.
yes. Won't take too long.
Yeah.
So the stack which you saw before is exactly this one.
That one.
This is the module.
Yes.
So and actually what you need, you have like a water tank where you have the water stored, and you need to pump the water through the stack.
Yes.
This is happening here. Like there's a pump, a process pump, feeding it and then getting with oxygen out.
Okay.
So this is called oxygen separator. Why? Because you have to get rid of the oxygen. Otherwise, your oxygen would always enrich here in the process.
Yes.
So there's like a vent or something, and you're usually venting the oxygen to the atmosphere.
Doesn't the oxygen go up and the water stay down?
Yes, exactly. But then you have to relieve it.
Okay, yeah.
So you just have to. But this is exactly the idea. It is on the bottom you have water, and on top of it you have oxygen.
All right. Okay.
So the oxygen is leaving here. You are mostly cooling it down to recover some residual water in the oxygen. But this is the general idea of this one. However, the water is super critical for a PEM electrolysis process. Like the water has to be in the right temperature, in the right amount, in the right quality, like there are no particles or ions or anything allowed in the water.
So I couldn't just take water out of a river
No,
like
please
that?
don't.
No.
Please don't. No, you do
okay.
this once. So
Okay.
no, please don't. So for at least for this process here, for our system in general, it is okay.
Yeah.
Because the system that you usually build, you have like a water purification at the very beginning.
At the very front. Okay.
So you get then some water, like tap water or something.
So that's what we're going to see.
It's being cleaned and then it's being fed here.
Okay.
So the point is, what you will also have to do is you will have to cool down the water, because when the water is going through the stack, there are some electrochemical things happening. There's heat is being generated.
Okay,
because you don't have an efficiency of 100%, so the dissipation.
But it doesn't boil, does it?
No. It's around 60, 70, 80 degrees.
All right.
Something.
Okay.
So
you want it then going in with a cooler temperature, like around what kind of temperature?
yeah, you have a delta T of 5 degrees maybe.
Right,
so
okay.
in this area over the stack.
All right.
But the point is, you have to get rid of the heat in the water.
Yes.
Right, because otherwise the water would heat up more and more, and
Understood.
you would exceed these 60, 70, 80 degrees. Which is why there's a second loop, which you see here.
Yeah.
You're cooling down some of the water
Yes.
here,
Yeah.
and then you're polishing the water. Polishing practically means when your water is passing by the pipes,
Yes.
it catches some ions, and also from the stacks and from everything it touches, it can catch ions.
You're
These will enrich.
deionizing it.
Exactly,
You're
exactly.
deionizing it.
And we have
Alright.
ion catchers here,
Okay.
deionizing the water and feeding it back into the
Okay.
separator.
Right. Okay. Okay.
So that's in general.
Okay,
it
so your
for this side.
purification, so water coming
Yes.
from here, purification in there in the tank, cooling, and then loop through the system. And this is the hydrogen side of it.
Exactly. What you see here is the
Yeah.
hydrogen side.
Yeah, exactly. Because one side you have the oxygen and water coming up,
Yeah.
and then here you have the hydrogen popping out. Yeah. Okay.
Exactly.
Yes.
So you have just 2 outlets here,
Yeah.
just 1 inlet, right? But 2
Right.
outlets here. And then for the hydrogen, you do exactly the same kind of. You have a hydrogen separator, and the water is on the floor, and the hydrogen's on top, and then you relieve the hydrogen, and this is your product of your process.
Yes.
So what's quite interesting, this hydrogen is usually at around 30 bars, maybe even higher pressure,
yeah.
because in this membrane, in this stack, it is building up a pressure for the hydrogen side. So you get already pressurized hydrogen from such
Coming
PEM
out from that.
electrolyzers.
Okay, and it's so the pressure comes from the actual electrolysis process. That's
Exactly.
going
In the this one membrane, really
Yeah.
per membrane, there's
Yeah.
a delta pressure
Yes, yes,
over a
yes.
membrane of around 25 bars or something. So it has to
already?
resist this pressure.
And it
yes.
can take that pressure. The
Yes.
membrane can.
Yes,
okay.
because it's not only membrane, you also have some layers above and
yeah,
on top
yeah.
it, and below it. So yeah.
Okay, so that's essentially your hydrogen side here, and then what I mean, just being curious, what do you have over here? This is the electrical.
Exactly. This is
aspect
the
of it.
electrical
Okay.
section because you need direct current on your stack.
Yes.
So there's usually first a transformer and then a
Yes.
rectifier on your system.
Okay, so now we've understood the basic process that you have several loops. Can we see how this looks in a real system, like one that you built?
Yes, sure, of course. So I brought here just an image from the 2 megawatt electrolyzer
right.
that we have built like this.
2 megawatts. So
Yeah.
sorry to interrupt you.
No,
but
sure.
so it's 1 megawatt per stack. Here.
Yes,
Yeah,
exactly.
I recognize these ones. These are the stacks. Yeah.
Exactly. So this is the stack that we saw before.
Yes.
Actually, see some screws here.
Yes.
This is just to tighten everything together.
Yeah.
Because as I said, you have 30 bar in there, so
Yeah.
things want to go apart from one another. So this is really a crucial aspect here. And the stacks are usually nowadays in the 1.25, 1.5 megawatt range.
How many cells are we talking here?
In between 100 and 200 usually in this
okay,
range.
okay,
yes.
okay.
So this is what you would find here. But so you add, you grow bigger by numbering up your stacks here.
Yes.
So you should find the stacks here.
Yeah.
This is this water separation vessel
Yes.
that we saw before for the oxygen.
For the oxygen, okay.
You pump the water, filter it again because I told the water quality is very important. No, polishing is here. This is really a
polishing is
filter.
over there. That's
This is just for catching very tiny parts that could be in the water,
Okay.
maybe from some components here. in the
What
process.
happens when the water is not as pure? What happens?
So your stacks will degrade over time, like a PEM stack, the membrane, the catalysts, and so on. So if, for example, you have ions in your water, they will bind to the catalysts,
so they
and then the
eat up,
degradation will increase.
Okay.
So and then your system,
Degradation means basically, it's no longer as good or some layer.
like with a
on it.
battery.
Yeah,
like a
like
battery
with-
degrades over time. It's
and then-
actually the
okay,
same what's happening
okay.
here.
So you essentially you're doing that to keep the stacks long and happy
Yes.
life.
Yes, exactly. And this
yeah.
is very, as I said, the system layout and how
Yeah.
you build the system is very crucial
Yeah.
to the longevity of these stacks.
Okay,
Yeah.
right. Okay. So yeah.
So you have this one here, so filter, stack,
Yeah.
back again to this vessel,
Yes.
venting the oxygen.
Yes.
And then here have a pump, heat exchanger, have these resins, the water polishing, and feed back the water to here. So
Okay.
this is what we've fixed.
Yeah, that was the ion remover. Then you have another. This is the fresh deionized water tank. I see.
Exactly.
Like your labels,
so,
yeah.
so as we said, we are losing water
Yes.
because water is spitting up.
Oh yes,
huh?
obviously. Yeah. The more water that's being lost, the more hydrogen we're getting.
Exactly.
out.
So
Yeah,
we,
it's
yes,
good
exactly
news.
like this. Yes. So we have to feed new water to the system.
Yes.
Right. So we have the water treatment, what we discussed before, and the water is just stored here in this tank. And then we're using this water from the tank to resupply this O2 separation vessel with water.
Tell me, a container is what kind of water can I put in there? Can I, well, okay, river water maybe on one extreme, but what kind of water am I putting in there? Or
So,
can I?
so it depends,
Yeah.
of course. I mean, you can actually purify nearly every water at the end.
Yes.
The question is just how big is the water purification system that I have there.
Understood.
So most water we are using, like here in Europe, tap water or something.
Yeah.
But still, you have to react to different water qualities that
Understood.
you're happening to find at the spot where you want to deploy the electrolyzer.
Okay, cool. And then over here.
Yeah, exactly. So over here is the hydrogen side
Right,
of the
okay.
system.
So the water side,
Yeah.
could one say? Water tank, hydrogen side stacks. Okay, and
Exactly.
and this is the water treatment at the beginning. Okay, so it's like
Exactly.
okay, from water to hydrogen. I
Yes,
like that.
exactly. That's right. Yeah, perfect.
Yeah.
Yes, exactly.
Yeah.
But I mean, what you have to do, you have to separate water from hydrogen as well, as we
Okay.
discussed before.
Yes,
This
yes,
is
yes.
happening here. By the way, this is smaller than this because the pressure is higher. So you need less volume actually for doing this.
Yes.
So you separate here, and then you go to the H2 purification. So why do you need this? When I'm doing a PEM electrolyzer, my quality of hydrogen after this one here is already at 99.9%. But if you want to use hydrogen, especially for mobility, for a fuel cell or something, you need 99.999, like 5.0. Exactly.
Ah, right. So what out of the stack, I'm getting 3 nines or
Yes.
maybe even 4.
Yeah, after this separation here, you cool it down a little bit, and then you have 3 nines.
3 nines.
Exactly.
Okay. So here, how do you just very quickly? How do you get the other 2 nines on there?
It's a PSA, a pressure swing absorption.
Yeah.
Like you have like 2 vessels.
Yes.
And in each there is like a granular.
Okay.
And then the hydrogen passes by. The water is being sucked in this granular, and then the hydrogen goes out like dry.
Okay.
Like the silica gel, you know,
Yes,
this what you have
yes,
sometimes
yes.
find in your clothes.
Yes.
So like
That
this.
absorbs that. Okay.
Like
okay,
this is being in there. So you have 2 columns usually, because this one is being loaded with water, obviously, when hydrogen is flowing through there,
Yes.
and there's more water.
Yeah.
And then there comes a time when it's fully loaded.
Okay.
So what's happening then? Your process is turning to the other column. So then the hydrogen is being fed through this one,
Okay.
and the second one is being regenerated in this time. So one is always in the regeneration phase, meaning sweating out the water that it has collected before.
Yeah.
And then you always go back and forth, right? Which is why this is called pressure swing absorption. It
Okay.
swings.
Right. Okay. And that's probably a lot of control going on there. You have to have some let's say programming and computer systems to do the automation that control that, and all the measurements. I have 2 questions. So at what we said that 30 bar, or what pressure hydrogen are we getting out here, out of this container?
We are getting out of this container hydrogen at 30 bar.
30
so
bar,
at the
okay.
outlet of the container.
Yes,
That means in the container you're already at higher pressures.
Yeah.
But 30 bar is the outlet pressure.
Okay,
of
and that
such
30
container.
bar was mainly generated within the stack already.
Exactly, within the cell, really. In the cell,
And
you're
another
generating.
question I have to ask you, and this is because I had an interesting conversation on another video about cell voltage monitoring. Do you
Yes.
guys have that in
Yes.
there as well? Okay.
It's
okay.
mostly so the stack suppliers.
Yes.
So we are integrators.
Yeah.
The stack suppliers usually supply you a cell voltage measurement, and then you can measure the voltage of each cell
Of
and
each
also
cells,
track
yes.
it over
Yeah.
time.
Yeah.
Because the degradation that we were talking about
Yes,
before
yes.
will be reflected in a higher voltage per cell.
Yeah,
So the
yeah.
voltage will increase from time to time.
Okay. So Max, I know you brought another model with you about it's like this system. I don't know whether we can get that on. Let me try. We had that over here, and there we go. Oh yeah. So there.
Yeah.
Because I mean, I found that pretty impressive, but maybe you can tell us, take us through how something like this would look if it's in my backyard now.
Yeah, so what I showed you before was a 2 megawatt system,
Yes.
right? So this here is like now a 5 megawatt system that we are having. Like you have these 3 containers. This one is for the power electronics.
So we have three containers.
Yes.
One which is kind of shaded here.
Yes,
we have
exactly.
this one and this one.
Exactly.
The one we just saw before. Which one would that be?
It's a mix between these two.
Ah, okay.
Because when you have only 2 stacks, you can merge like both containers into one.
Okay, yeah, where you
But
go
when it's
from
getting
water
bigger,
to hydrogen. Okay,
exactly. But now this is happening in both containers in parallel.
Right. So you have all the stacks here and the balance of plant elements.
Exactly.
There.
So what you will see there, for example, is the water treatment. There's the gas treatment and so on. So it's process-wise, it's nothing different from what we saw before.
Okay, but to be honest, I thought that you're making these containers because you want standard, you know, like containers, basically standard systems. Yeah. And now, isn't this like a deviation from the standard when you say, nah, this container I'm going to do different. Now I'm going to make 2 containers and then put
okay. Very good question. No, so actually we have 2 standards for 2 different sizes. So like you standardize the 5 megawatt, which is like what you see here.
This is 5 megawatt.
This is 5 megawatt, exactly. You can count here.
So, okay.
You should see 1, 2, 3, 4, 5 stacks.
All right.
So like we add 5 stacks to 5 megawatt here. This one here, this green one you see is the oxygen separator.
Okay.
It's really big right now, as you see. But for the 5 megawatt, this is a standard platform. And also if we would do a project with 10 or 20 megawatt, we would do multiples of this one. So it would be twice this container arrangement. Right?
Okay, but so this is a standard for the 5 megawatt setup, and the other one is a 2 megawatt setup.
Exactly.
It's started in itself. Okay.
And that's it. So these are the 2 standards we go with, and all the sizes that we need to do, we do with these 2 platforms.
Would be multiples of this
exactly.
essentially. Okay.
Exactly. Yes.
Right. Okay. Okay.
So and what you see here on top, what is new, what we didn't discuss before, is a dry cooler. So for just getting off the heat from your water.
Okay, so essentially the outside part of that heat exchanger, which we saw on the PNID.
Exactly.
Before.
Exactly.
Okay, so that's big. They get pretty big. Okay.
Yeah.
And then this is also for the cooling.
Yes, exactly. This is like the pump and everything that you need there, and also there's a chiller. I don't know where you can see this, but so all the cooling components are usually obviously placed outside of the system.
Okay, tell me what. So this we talked about. You said this is a power. What's going on in there?
It's a power box. So what you need to do, you need a transformer to transform your voltage from your grid to a lower voltage.
Okay.
Because a stack runs at maybe 300, 400 volts, or rather like 300 volts roughly.
Yes.
So adding 5 stacks would lead you to 1500 volts.
Yes.
So you need to transform power from the grid usually down.
Okay.
And then you need to rectify it because you need to get from AC to DC.
To DC. Okay.
Yes.
Okay. So that's all what happens in there, and that goes to there. Okay. So just for your part, the PEM electrolysis, which is your specialty, this is what you do. This, you know.
When we do a project, we offer like everything as a turnkey solution. Like we supply with all of this. I mean, obviously we would not build this ourselves. Also, me personally, I really don't understand what's happening in there. I just understand you get DC current out
you
there.
have the requirement of what current you want coming in there. Okay, perfect.
That's it.
Max, we have little time left, but in the presentation, I think we had some photos still of some real systems. If I'm not mistaken, can we just pull this up?
Yes, sure.
No, so this is how it looks in real.
Exactly. So this is a megawatt system. This is how it would look in real from the outside.
Yes.
So practically what you see here on top is a little bit. This is dry cooler, all the pipings, and it's really a container stuffed with technology. So lots of things happening in there.
Isn't it hard to keep this running? I mean, how long can this run?
So
can it run by itself?
Yes. So in general, it can run by itself.
Yeah.
And it's usually, I mean, for such a system, it's best if it just keeps on running.
I mean,
like also with your car or something. The best is just to keep it running and never turn it off again, right?
Okay.
So,
but then come the humans, who only sometimes need it.
You need to do service from time to time, but in general, you want to keep the system warm, want to keep everything running.
All the time. Okay.
It's just a picture from the inside, so you get a little bit an idea. There are valves, pipings, sensors.
But all of this, so this is essentially what you put together for an entire system, and then instead your customer at the end is getting hydrogen, or he's getting that plant.
Exactly.
He's getting that plant.
Exactly.
So he can then operate it.
Exactly. So he's not getting a stack only from us and has to take care of the plant
Yeah,
or
yeah,
something. He's really getting everything and can start operating and producing hydrogen.
Okay, so I know I said this in a certain way, your customer, but essentially, I mean, it's about understanding how these PEM electrolyzer systems work, and then we see that you can't just put a cell on the table and say, okay, now start doing electrolysis. You need a whole system around it. I quite like this picture that you brought here. Can you just tell us about this very quickly?
So this is our first operating system. It is in Brazil. It is close to Fortaleza, like in the north of Brazil.
Right.
So which is what you're seeing here, and actually it's an electrolyzer, 1.3 megawatt in this case.
Okay.
Which you see here. By the way, this is this power container that we were discussing before.
Yes.
And it's being implemented in a hard coal plant, power plant.
So this is a coal power plant in the background, and then
and
nice.
they are having the electrolyzer now for producing green hydrogen because they need hydrogen for the process to cool down.
And it wasn't a problem to put that beside a coal plant. I mean, with all the pollutions and all that.
I mean, of course, you have to comply with safety regularities and everything. But I mean, these are all ATEX protected things that you're using in your system. I mean, then you also have a fence. I mean, here you see it, I think, around it.
No. I was just thinking about sometimes when the systems operate, they have certain air quality, but you don't have so much air going in. There's more water.
Yes, exactly. We need the water quality is what is very important.
Max, can you just, as an outlook, tell us? So where is this going? I mean, it's great that you guys have now, the standardized model, 2 megawatt, 5 megawatt. So what's your vision of the future? How do you see things going at the moment?
So what I see is we need a numbering up, and we will do a numbering up of these systems, right? I mean, the systems will get slightly bigger, but especially they will get more numbers. So it's very important to get these systems industrialized.
Okay.
So you will be able to produce one by one and not doing a project individual job always, but it has to be a standard system. And then, I mean, there are so many demands for hydrogen. I mean, you know better than I, but these systems can really help in order to fulfill that.
What I must say, we had a bit of conversation before this. I know that you're a production guy, actually. So it's actually good for all the hydrogen people out there that the production guys are coming in, because I think you're going to help us serialize this more and get like many more out there. And I think container, just like they did in the shipping industry, can do a lot to standardize things and get things going. Max, it has been an absolute pleasure having you in here. Thank you for explaining us, taking us through an entire system. And thank you for watching. If you've enjoyed this, please give us a like. If you want to know more about the hydrogen economy, there's more videos here on this channel. You can also go on Hyfindr.com, where you find all the technology that you need to make the Hyfindr, the hydrogen economy work, including such electrolyzers. Thank you for watching. Please follow us or give us a like or whatever, and just enjoy your day building the hydrogen economy or whatever else you're doing. Thank you very much for watching. Thank you, Max.
Thank you very much.
Goodbye.